All right, this is just part 2 on the notes for the dimensional analysis and calculations of going between numbers of atoms or molecules, formula units, and numbers of moles, and then a little bit more. So you can see in this example up here where we're given the 3.58 moles of sodium chloride and we want to know how many total atoms. It's a little bit different. We're going to again start with the value given, 3.58 moles, cancel moles, and then we can go to molecules because we can go from moles to the number of something. So in this case we can only go from the same unit of NaCl. So 1 mole of sodium chloride is Avogadro's number of molecules of sodium chloride, and then we're going to cancel molecules of sodium chloride to get to total number of atoms, using the relationship that in this case there's 2 atoms per molecule because there's 1 sodium, 1 chloride. So then you end up multiplying by 2 and you get that answer there. Similarly on the next one, 18.95 moles of calcium hydroxide. Again, going from moles to formula units. And I should have set up here that this should have been formula units, not molecules. That was my mistake because this is an ionic compound, but it really doesn't change the calculation. So anyways, we've got formula units here for calcium hydroxide because it's ionic. 6.02 times 10 to the 23 per mole. That gets us into formula units. And we want to know how many total atoms again. So in this case, because of the formula of calcium hydroxide, which this is where your nomenclature is going to be important because I might just give you the name calcium hydroxide, not actually give you the formula. So then we've got Ca and then in parentheses OH2. So there's 1 calcium, 2 oxygen, 2 hydrogen, so there's 5 atoms per formula unit. And then you just calculate across. Just keep in mind, remember, any number on the top you multiply, any number on the bottom you divide. The next one, if you want to know how many atoms of carbon are in 4.19 moles of C6H12O6, which is sugar. So we've got 4.19 moles of sugar. And then we're going to go from moles to number of molecules using Avogadro's number. And then we can use the relationship for 1 molecule of sugar has 6 atoms of carbon from the equation. So multiply those across and you get 1.51 times 10 to the 25 atoms of carbon. So it's going to be important that when you do your labels on these that you include all the information, not just saying moles or molecules, but putting the formulas of the things you're using, because later on that's going to become even more important when we start mixing different molecules together. And the last one here, probably the trickiest one here. So we're going from the atoms just of hydrogen that are in a sample of methane, which is CH4. And we want to know how many moles we have. So we're going to start with the number of atoms of hydrogen. And then we're going to go from atoms of hydrogen to molecules of methane. And there's 4 atoms per molecule. That gets us into molecules. And then a molecule of methane, cancel molecule of methane, and then we can go to moles, which is what we want, and then it's using Avogadro's relationship. So then it would just be multiplying 3.99 times 10 to the 24, divided by 4, divided by 6.02 times 10 to the 23.